Okay, in today's lesson, you'll be learning how to find maximum or minimum values of expressions in a region defined by a set of inequalities. Okay, so that's the topic for today. We've already seen how to represent a set of inequalities graphically, that we've seen that before the school closed. Now, I hope you've downloaded the notes and kept the copy with you. Okay, so I expect you to copy these examples in your exercise book, or if you decide to print, make sure you stick them in your exercise book. Okay, let's get started with finding the maximum and minimum values of expressions in a region defined by a set of inequalities. Let's look at two examples I have here for today. Example 1 would be try it 15 from your textbook to find the maximum and minimum values of 2x plus y for points in the unshaded region R defined by these three inequalities. So once you have these three inequalities, we need to draw them out. Okay, so I will first write down the border lines for each of the inequality. So we have the first border line, 2y plus x equal to 8, x equal to 2, and y equal to 1. I've written down the three border lines here. Once I have the three border lines, I can draw these lines on a graph paper. Okay, so x equal to 2, y equal to 1 are special lines. X equal to 2 is a vertical line that passes through the x-axis at 2. Y equal to 1 is another special line, a horizontal line that passes through the y-axis at 1. Now, 2y plus x is a slanting line. For that, I need to have some points to be plotted to be connected to form a straight line. So I'm going to make y the subject here. Making y the subject, take the x to the other side, divide by 2. Okay, so I have negative x plus 8 over 2. Y equal to negative x plus 8 over 2. So choose a few random points for x and find the corresponding values of y. When x is 0, we get y to be 4. When x is 4, we get y to be 2. We have seen all this in the previous lesson we had. So I've drawn the line. So I have three lines, a set of three lines drawn on the graph paper. Now we need to shade the inequalities, the unwanted, to represent the region R defined by these three inequalities. So let's try shading them. So if I want, I've got the shaded region here. So 2y plus x equal to 8, 2y plus x less than or equal to 8 would be the region below the line. Above would be more. So I've shaded the region which is unwanted in pink here. Okay. Then x more than 2, more than or equal to 2 is the required region. The region on the left is unwanted. I've shaded that in blue. Okay. Y more than 1 is the region which is required, more than or equal to 1, which is above. The region which is below is unwanted. I've shaded that in green. So when you shade the unwanted region, you get the required region. I have labeled the required region as R. So this is the required region that we need, which satisfies all the three inequalities. So that's the first part of the question. Now let me go back to the question. It says to find the maximum and minimum values of 2x plus y for points in the unshaded region. So I've got the unshaded region R. That's the first part. Now I need to find the maximum or minimum values of 2x plus y. So for that, I'm going to draw this line 2x plus y equal to 0. Okay. So I'm going to draw the line 2x plus y equal to 0. To draw a line, again, I need points. So I've chosen a few random values of x, negative 1 or 0. It could be any value that you want to choose. I've made y the subject here, y equal to negative 2x. So for the chosen random values of x, find the corresponding y. When x is negative 1, y is 2. When x is 0, y is 0. So I've drawn the line 2x plus y equal to 0. So I've drawn this line. I need to find the maximum, minimum values of this line. Okay. Now I need you to place your set square on the line. So this is your line. So you place your set square on the line. Okay. Just hold on for a minute. I'll show you something. Okay. So you see a new screen here now. So I have to place the set square on the line. Okay, you see the line here, 2x plus y equal to 0 is the same diagram. I've just enlarged it so that you can see it clearly. Okay, so I have this set square placed on the line. Okay, and where you see the set square 90 degrees, you've got a pair of set square in your instrument box. You can use any of the two set squares that you have there. So place your set square on the line like this with the 90 degrees edge along a ruler. Place a ruler along the other arm of the 90 degrees here. Okay, so place it here along the set square. Now fix the position of the ruler. Hold the ruler tight. We're going to draw parallel lines that are parallel to 2x plus y equal to 0. You see there's a line here. I'm going to draw lines that are parallel to this given line. And I need these lines to pass through the triangle, the unshaded region R. So for that, fix the position of the ruler. Hold the ruler tight with your left hand. Okay, so slide this along the edge of the ruler. Okay, the position of the ruler must be fixed. It shouldn't touch. You see the set square moving until you reach the first point on the triangle. You see the point there? This is the first point on the triangle. Now I can draw a line here. Okay, let me try drawing a line. Okay, so draw a line that passes through. You fix the position there and you draw a line passing through the first point of the triangle. Now, after you draw the line, you again hold the set square and the ruler. Hold the ruler in the same position, hold it tight and slide it further. Slide the set square further through the triangle. You see it crosses through several points. You see there's a point here that it crosses through. There are several points, okay? And now I'm looking for the extreme points only. I've got the first point. This is another point. You see the other vertex there. That is another point. You see this is another point. There are points here. There are several points on the triangle. I'm looking for the first and the last. You keep moving until you get several points. There, you have another point here. Another point there. Okay, until you reach this point here. Okay, and always remember, the ruler should be fixed in the position. Okay, so now at this position again, you draw another line here. Let me draw the line for you. Okay, there's another line for you here. Okay, now let me remove the set square. You see that? We've got pair of parallel lines. Both are parallel to 2x plus y equal to 0. So this is the first line that passes through the first point in the region R. This is the last line that passes through the last point in the region R. Okay. Okay. Can you see the screen here now? Can you see the new dialogue here? Okay, so I've got the first line and I've noticed it passes through 5. So I've written 5 here. Okay, I've got the last line. If you see the whole graph, I'm sure it will pass through 13. So I've marked 2x plus y equal to 13. Okay. Okay. So I'm finding the maximum and minimum values of 2x plus y. So this is 2x plus y equal to 0. So this is the first point. And as you draw the parallel lines, you have several parallel lines that can be drawn in the triangle, the unshaded region R, the white region R. So I'm looking for the first point and the last point. The two extreme points will give you the maximum and the minimum. Other lines that pass through the triangle will give you some values, but they will not be maximum nor minimum. Do you follow that now? The objective is to find the maximum and the minimum value, which can be obtained only at the extreme positions of the triangle. And those lines should be passing through those extreme positions, and they should be parallel to the line 2x plus y equal to 0, because we are looking for maximum minimum values of 2x plus y. I hope I've answered the question. Any other doubts? Okay, thank you. Let's move on. So now that we have drawn two lines, and you can notice the points there, 2, 1 and 6, 1, the coordinates. Okay, now we will be substituting these coordinate points in the expression 2x plus y. We are looking for maximum minimum value of 2x plus y. So I'm substituting x to be 2 and y to be 1 in that expression there. Okay, so that's 2 times 2 plus 1, you get 5. 2 times 6 plus 1, you get 13. So 5 is obviously the smaller value and 13 is the larger value. So maximum value of 2x plus y would be 13 and minimum value of 2x plus y would be 5. Okay, so you're looking for maximum and minimum values. So you can generalize that you will find these maximum minimum values only along the vertices of the unshaded region. This is the unshaded region. It forms a triangle. So I can find the extreme points. You see there are 3 vertices here. But this is your first extreme, this is your last extreme. So your extreme values will give you the extreme minimum or the extreme maximum. The other points will be in between the mixed maximum and minimum values. Okay, so that's one method of drawing parallel lines to the expression that is given. Draw the line of the expression and find parallel lines. That's one method. I do understand it is a bit tedious. So there's an alternate method, which is much simpler. Okay, let's look at the alternate method. So it's the same region that we have, region R here. And now region R is given by a triangle. Triangle has 3 vertices. So I've written down all the 3 vertices, 2, 1, 2, 3, and 6, 1. Okay, 3 vertices. So as I said, the note here, in general, maximum minimum values of given expression must occur at one of the vertices of the region satisfied by the inequality. So extreme values will be at one of the 3 vertices only. Okay, so I can find the value of 2x plus y at all the 3 points, all the 3 vertices, at 2, 1, at 2, 3, at 6, 1. Substitute the values of x and y. You get 5, 7, and 13. Okay, so your extreme values are again 5 and 13. You see 7 at 2, 3. So this is a value in between 5 and 13. That is not an extreme value. It is neither maximum nor minimum. So lines passing through the region will not give you maximum or minimum. Only the extreme points will give you the maximum or minimum. I hope this is clear. Example 1. Is everyone clear with this? Do you want me to repeat any part again?
No.
Okay, thank you. Okay, if you want me to repeat, please text. If you don't want to speak, the text is only between you and me. The others cannot see the chat. Okay, I have disabled chat between each other. So all that is entered in your chat is only visible by me. So feel free to write down. Okay, moving on. Let's look at example 2, try it 16. So the question is, if x and y are integers, integers are, they are whole numbers. They can be positive, they can be negative, but we don't have fractions, we don't have decimals, rational, irrational numbers, and so on. Okay, so they should be whole numbers, either positive or negative. To find the values of x and y such that y minus x is minimum. Okay, so this is the expression that we need to look for, given that x and y satisfy the following inequalities. Like the previous question, I will list down all the boundary lines: x plus y equal to 6, y equal to 3 minus x, x equal to 0, and x equal to 4. Once you have the 4 boundary lines written in this case, I'll find x equal to 0, x equal to 4 are special lines. X equal to 0 is nothing but your y-axis. And x equal to 4 is a vertical line passing through the x-axis at 4. Now I've drawn it dotted here because it's x less than 4. There is no equal sign, so I draw a dotted line here. The rest are all less than equal or more than equal. So the rest of the 3 would be solid lines. Okay, so x plus y equal to 6, making y the subject. Choose some random values of x and find the corresponding y. Similarly, y equal to 3 minus x, y is already a subject. Choose a few values of x, find the corresponding y, and draw the lines out. Plot the points, draw the lines out. Not necessary you have to follow the same point. You can choose any points to draw the lines. Okay, once you draw the lines, you see you have y equal to 3 minus x. Make sure you label the border lines. X plus y equal to 6, the y-axis, and x equal to 4, the dotted. Once you have these drawn, we will now shade the unwanted region to find the required region. Okay, looking at the unwanted region. So I'll start with x plus y less than or equal to 6. Okay, I need the region which is below. Less than is below. More than is above. Above is the unwanted region, so I shade the unwanted region. Okay, so shading it in red. Similarly, you have y equal to 3 minus x, the borderline. I need the region which is above. Y more than 3 minus x, so I need the region which is above the line. Unwanted is the region below the line. So shading below the line. Okay. Next, we have x more than 0, more than or equal to 0. I need the region which is on the right. Unwanted is the region on the left, shading the left side of the line. Similarly, we have x less than 4. So more than 4 is on the right, which is unwanted. I shade the region which is unwanted. When I shade all the unwanted regions, I end up with this region R. The unshaded region R satisfies all the 4 inequalities. Now, what does this region represent? It is a parallelogram. Okay, so moving on, let me go back to the question. We are looking for the minimum values of x and y such that y minus x is minimum. Again, there are two ways of finding the minimum values of y minus x. So I can draw the line y minus x equal to 0 first. Okay, so y minus x equal to 0, making y the subject, y equal to x. So choose some values of x, find the corresponding values of y. Just like the previous case, we need to draw parallel lines. So I first draw y minus x equal to 0. Now I need to draw lines that are parallel to this line, okay? And it should pass through the region R. So I have extreme points. Parallel line, this is one extreme. Y minus x equal to 6 is one extreme. So I have several lines that I can draw. Okay, several lines that I can draw. And the other extreme is y minus x equal to -5. This is the other extreme. But I can't use this point. Why? Because it is on the dotted line. Points on the dotted line are not included. So I need to go for the next line. I can think of going for this line. There can be a line which is parallel and it passes through 4, 0. Again, 4, 0 again is on the dotted line. So I can't take that point. So move in further. I can go for irrational values also, but x and y are given to be integers. So I'm looking only for whole number points here. Okay. So there's another line here. We have 2 points here. 4, 1. Again, it is on dotted line, so cannot be considered. The next point would be 3, 0. So that's the other extreme. So the first extreme here was 0, 6, and the other extreme is 3, 0. So I've spotted the two extreme points in the shaded region, excluding these points. Because they are on the dotted line, they cannot be considered in this case. So once you've identified 3, 0 and 0, 6, I can find the minimum value of y minus x using these 2 points. Okay, let's find the minimum value of y minus x at 3, 0 and 0, 6. So at 0, 6, y minus 6 would be y is 6 minus x is 0. I get 6. At 3, 0, y minus x would be 0 minus 3. You're just basically substituting the values of x and y in y minus x. You get -3. You see, this is the maximum value 6 and this is the minimum. Since the question is only asking for the minimum and minimum value of y minus x is -3, this happens when x is 3 and when y is 0. So we're looking for the values of x and y so that y minus x is minimum. Okay, I put a note for you that why we do not consider 4, -1, 4, 0, 4, 1, because they lie on the borderline x equal to 4. And since we have x less than 4, those points are not included in the inequality region. I hope this is clear. This is using parallel lines. I know drawing parallel lines is tedious. So you should know the concept, how we get the extreme points, but you can also try the other alternate method. This is much simpler. I normally prefer doing the alternate method, this method, rather than drawing the lines. This is much simpler, but it takes a bit more of careful reasoning here. Okay. Now, since the region R is represented by a parallelogram, okay, region R is a parallelogram, it has 4 vertices. So I have 6, 0, 0, 6, 0, 3, 4, -1, and 4, 2. Okay, I've made a note here, 4, 2 and 4, -1 again cannot be considered because they lie on the dotted line. So if you have points that cannot be considered on the dotted line, you go for neighboring points, okay? So I'm going for definitely 0, 3 and 0, 6 is in. I need a point which is neighboring point to this. A neighboring point would be this, which is again a dotted line, or this point. So I can take 3, 0. I've taken 3, 0 here. A neighboring point to this would be, I can go for this point, okay, or I can go for this point or this point. You can test out on all the points. You can also test out 3, 3 neighboring points. You can go for 1, 2 and 3. You can test out on all the 3 points, okay? So you list down. I've just chosen 3, 0 and 3, 3. You can also look for this point here, okay? But since this is out, we can go for neighboring points. This, and this, okay? But when we've seen that through the parallel lines, this would be the extreme, okay? So I did not look into this value here. Even if you find out, okay, let me write it out for you. So if I look for the point 3, 2 and 3, 3. 3, 3 I have taken, I think, yeah. So 3, 3 is taken, 3, 1 and 3, 2. Let's decide for at 3, 1. Y minus x would be 1 minus 3, which is -2, okay? Then at 3, 2, y minus x will be 2 minus 3, -1, okay? So you see those points there? -2, -1 here. Okay, so you're looking for the minimum value. Obviously, -3 is the minimum here. You can test out on several points, okay? So that's the reason we do parallel lines, where we get bang on the extreme point right away. If you're using this method, you need a bit more of careful reasoning here, just to make sure that you're not going wrong. We take a few points, neighboring points, if the points on the border lines are not included. So when you notice that -3 is a minimum, you can go for minimum value of y minus x is -3 at 3, 0. Hence, x equal to 3, y equal to 0. This happens when x is 3, y equal to 0, y minus x is minimum, which is -3. I hope this is clear so far. Any questions to ask?